So hi everyone, I welcome you all to the fourth lecture of the thermodynamics. So this is the fourth lecture. So here in the last class we have introduced the concept of thermal equilibrium. Where we said that if A and B are in equilibrium, then there should be some quantity which has to be constant, and we have discussed that the temperature is the one. Then we have discussed the zeroth law of thermodynamics, where we have discussed if A and B and B and C are in thermal equilibrium, then there exists a thermal equilibrium between A and C. So far we have discussed about this thermal equilibrium, zeroth law of thermodynamics, and we have come to the notion of temperature. So zeroth law of thermodynamics led us to the notion of temperature that agrees with our intuition. And so we can define temperature as we already defined in the last chapter of thermal properties of matter. So temperature is the measure of the degree of hotness of the body. Okay, so this is all about the last lecture. Now today what we will going to discuss is, I introduce first law of thermodynamics, I will be going to discuss the three important concepts that are internal energy, then degree of freedom, and law of equipartition of energy. So when we say there is a body, if I have a body, let's say something like this, and this is at ah height from the ground, and it is moving with some velocity v in horizontal direction. So, and there exists some gas inside this. So if I have to write the total energy of this system, so I have to write the total energy of the system, then we know what it should be. So in a very general term, we know there is a kinetic energy, then what else, because it is at a h height from the ground, then there exists a potential energy, but still this total energy of the system is not complete. So there exists some more energy, and that is internal to the system. So that does not depend of this motion or this height of the, that does not depend on this height or this velocity of the body. It is internal to the system, and that we called as internal energy. So this is kinetic energy, this is potential energy, and the new one that we are going to discuss in detail is, and that are important for the thermodynamics, is that is internal energy. Okay, so internal energy does not depend on the motion of the body. Also, it does not get affected at which height it is there. So internal energy is very internal, that is, so we need to go into the molecular picture to understand the internal energy. So we have to understand the molecular picture to understand the internal energy. So internal energy is because of the molecules present inside the body. So these are the molecules that I told before. So these are the molecules. Because of this, there is some internal energy of the body. So internal energy is the sum of total energy of the molecules inside the body. Now, if there is a molecule, let's say this is the molecule inside the body, so which kind of energy it has? So it can, let's say, it can move, in some direction, let's say x, y or z, with some vx velocity, vy velocity or vz velocity. So these molecules can have kinetic energy plus there may exist some molecular interaction. So there is a possibility of molecular interaction, and that interaction can be understood in terms of the force present between the two, force of attraction between the two molecules. So let's say this is another molecule of the same gas, so I can make it with this. So this is another molecule, so this is interacting with this molecule, and there exists a force, some attractive force. I already told you that some interaction in the properties of solid, that this attractive force is mostly the van der Waals interaction, and this comes from the Lennard-Jones potential. So these are just the extra details, don't worry about that, but this attractive force is actually leads to the notion of potential energy of molecule. So this is the and this leads to the some force of interaction. And a better way to show this is some force of interaction that leads to the potential energy. This is the kinetic energy because of the velocity of the molecule, and potential energy because of the attractive force between the molecule. And there may exist one more energy that may or may not exist, because that depends on the temperature of the body or the molecules inside that. And so this molecule can vibrate along its position. So this can vibrate, and so this energy we can say as vibrational energy, but this only comes at higher temperature. So in general we shouldn't worry about this vibrational energy. So one point to note is that keep it clear that we are not studying now as a system. We are not studying the motion of this body. We are studying the motion of the molecules exist inside this body. So here it is the kinetic energy because of the velocity. Because of the velocity, there may be a velocity in x direction, y direction or z direction. Then there is a force of attraction between the molecules, that is so we have a potential energy, and then we have a vibration energy that comes at higher temperature. So this when we I will introduce the bifurcation of kinetic energy, where there is a kinetic energy because of the rotation also. So I will discuss it, because we are considering one molecule, so that is it is not easy to discuss here. We will be discussing in the later lecture. So this potential energy also is not the potential energy because of some height or some external force. It is essential because of the interaction between the two molecules, or the two molecules exist inside this body. So that is all about the internal energy. So when we discuss internal energy, we do discuss the system at rest. So we should be so this system must be at rest. So this system must be at rest. So this is the total internal energy. So the total internal energy can be written as the kinetic energy plus potential energy plus some vibration energy that exists at higher temperature only. Okay. So when we discuss notion of internal energy, we discuss it when the body is at rest. And so when the body is at rest, so the total energy of the system should be just the internal energy. I can note this as, so this is the kinetic energy of the molecule, potential energy of the molecule, and vibration energy of the molecule. Okay, so the total energy of the system is equals to the total internal energy. Okay, so this is all about the concept of internal energy. So for ideal gas, if we consider ideal gas, we will also learn that in the kinetic theory of gases, but for now the main assumption of ideal gas is there is no force of attraction among molecules. So this is the important assumption for the ideal gas. So I left you here with this thought of ideal gas, and in the next lecture we will be going to discuss the degree of freedom. Thank you.